Hi everybody, so today we're going to be talking about thyroid hormone and what happens with thyroid hormone after it leaves the thyroid and before it gets into the tissues, or when it does get into the tissue. So let's go ahead and get started. And this is looking at a follicle cell from the thyroid gland. And if you remember, I did a video on what happens inside of here and how we make thyroid hormone. So in this video, we're going to look at what happens from here until it gets over to a tissue. So if you recall, we make two different types of thyroid hormones which make up thyroid hormone. The first one is triiodothyronine, and the second, which is known as T3, and the second one is thyroxine, which is T4. So what's going to happen is these are going to leave this follicle cell and enter into the bloodstream, okay? So on the T3 is going to make up only about 7% of the thyroid hormone that's released. Now, some books will say there's a different amount. I'll get to that in just a minute. And then we have T4. T4 is going to make up about 93% of the thyroid hormone that's released. Other books may just say it's 80 and 20, but I'm going to go with 93 and 7 for right now. So now, these enter into the bloodstream, and here's what's going to happen, is they're going to bond with a plasma protein, okay? So we have basically three different types of plasma proteins. The most common one is something that we call thyroxine binding globulin, or just TBG for short. Thyroxine binding globulin, or TBG for short. That's what most of these will bond with. Now, the other thing it'll bond with is something called thyroxine binding prealbumin, or it'll just straight bond with albumin. But for the most part, when these bond, about 99.5% of T3 will bond with some type of plasma protein. On T4, it's going to be about 99.98% is going to bond. What that means now is that I have about 0.5% of my T3 is floating free in the plasma. It also means that about 0.02% of my T4 is going to be floating free in the plasma. So there's my T4 and there's my T3. But if you remember, I have far more T4 than T3. So actually, even though more of this is bound to this thyroxine binding globulin or other plasma proteins, even though it's more bound, I actually have more of this floating free in the plasma. Now, over the course of the next week, after this is made, what's going to happen is some of this T4 is going to lose an iodine, and it's going to become T3. So iodine is going to come out and it's going to become T3. Okay. This will also be released over the course of the next week. This will stay bound to this for about 6 days. This doesn't bind to the thyroxine binding globulin as strong as this. So this only stays on there for about a few hours. But let's take a look now at what's going to happen next. So I'm going to have my T3 and my T4. They're going to leave the bloodstream and they're going to enter into some type of tissue. Okay, so they're gonna actually, once they're in here, they're gonna bind to another protein. But let's look at T4 first. So like I just said, this is going to bind to another protein in here, and basically it's gonna be stored for future use. However, what's gonna happen is when it's needed, the T4 is actually going to lose an iodine. Okay, remember, we're already losing some over here, but once it gets inside here, it's going to lose an iodine and it's going to become T3. Okay, there's two ways that this can happen. So if I have a tissue, or if this is inside something such as the liver, the kidney, skeletal muscle, or the thyroid gland, I'm going to have what's called a type 1 deiodinase, which is going to remove this iodine. And like I said, I'll explain some more about this in just a minute. So here's a type 1 deiodinase. Now, if this is inside the CNS, if I'm in the CNS, the central nervous system, or if it's inside the pituitary gland, or if it is in the placenta in a developing fetus, I will have a type 2 deiodinase, which is going to remove this iodine. Okay, and it's going to be, if it's in here, it'll be a type 2 deiodinase. Now here's the thing about these, is that on these I have, or both of these are what we call 5', 3' deiodinase. So deiodinase, remember, if it ends in ASE, it means it's an enzyme. Deiodinase means it's going to take iodine off. So let's take a look at how that happens. If you recall, when we have thyroid hormone, we are going to have 2 benzyl rings that look like this, and they're attached to each other. Where you see these little corners here, that's going to be where carbon is, and we're going to number these. So this is carbon number 1, carbon number 2, carbon number 3, carbon number 4, 5, and 6. And this is considered my inner ring. When we were making these, this was the innermost portion. Now, this benzyl ring is just like this one, but it wouldn't make sense to number these using the same number. So now what I'm going to do is I'm going to call this 1', 2', 3', 4', 5', and 6'. So my iodines now are going to be attached at 3 right here, and at 5 right here, and at 3' right here, and at 5' right here. So what the 5', 3' is going to do is it's going to remove this iodine that's right here. So this enzyme is going to come in, and it's basically going to take this and remove it. Now, if you look, how many iodines do I have now? 1, 2, 3. I had 4. That's why we called it T4. Now I have 3. 1, 2, 3. So now it's T3. Okay. There's one other deiodinase that I haven't talked about yet, and we call that type 3 deiodinase. And what type 3 deiodinase is going to do is it is going to remove this iodine and not this one. So I'm going to put this one back here. I'll write it in black so you can see it. And then what it's going to do is it's going to remove this iodine. So when it removes that now, what happens is now we have 3, right? We have 3, 1, 2, 3 iodines. But this one's gone, but we need that one there. So because it removes that one, we actually call this reverse T3, and this is inactive. Okay, so that's going to be inactive. Okay, normally that doesn't even leave the thyroid. So now let's take a look at what's going to happen inside my cell. So if I go over here like this, and what's going to happen now is inside the cell, if you notice, we have this right here. This is going to be called thyroid hormone receptor. Okay, or we just call it TR. Okay, this is the thyroid hormone receptor that's right there. This one here is going to be called, we call this retinoid X receptor. Or we're just going to call this RXR. Okay, we just call that RXR for short. Now, these are what we call a heterodimer. What I mean by heterodimer is they're 2 different proteins, but they're bound together. So basically, we just call that a heterodimer because it's 2 different proteins. Dimer meaning 2, hetero meaning they're different. So let's take a look now. So here's my T3, and my T3 is going to come, and it's going to bind onto this thyroid hormone receptor, and it's going to activate it. But before I get there, there's something I forgot real quick. The area of the DNA that these are in is a transcriptase. This is going to be called thyroid response element. Okay, and that's this area that's going to be right in here where these are attached to. So now, once the T3, oh, by the way, and T3 is more likely to bind there by about 10, it forms a strong, 10 times stronger bond or bind than T4 does. T4 can actually activate this also, but T3 is more likely to do it. So here's what's going to happen is once this is activated now, it's going to either turn on the DNA, so we start making proteins, or turn it off. So let's say it turns it on, and what it's going to do is it's going to make messenger RNA. Okay, the messenger RNA from here is going to go out over to a ribosome that's over here. So here's my ribosome. right? And if you recall, the ribosome is going to make proteins. So I will have a protein being made. It's actually gonna make several different proteins, right? And basically the proteins it's going to make is it's going to make enzymes, okay? It's going to make transport proteins, and it's going to make structural proteins. So basically what these are going to do is they're going to increase the cellular activity. So not only does thyroid hormone play a role in making the genes produce proteins, but it's also going to play a role in non-genomic activities inside the cell. So when we have cells such as heart cells, we have adipose tissue, or even in the pituitary gland, what this will do is actually play a role in the cytoplasm or on the cell membrane. So one of the things that it's going to do is it's going to increase how sensitive ion channels are. And it's going to start allowing more sodium to come into the cell. And when more sodium comes into the cell, the sodium potassium pump, or the sodium potassium ATPase, has to pump that out, right? The other thing it's going to do is it's going to play a role in oxidative phosphorylation. So in other words, it's going to help make ATP. It's going to play a role in converting ATP to a second messenger, which we call cyclic AMP. And it's also going to activate protein kinase A in the cell also. So that's it for thyroid hormone and what it does after it leaves the thyroid and once it gets into the tissue. I hope you enjoyed the video. Thank you so much for watching. And if you liked the video, please hit the like and subscribe button, and we'll talk to you later.